Okay, so today we're going to look at how to run an independent samples t-test in SPSS. I'm running version 28, so a couple of things might be slightly different, particularly when we calculate the effect sizes or the Cohen's d, but everything else should be roughly consistent. And then there's a variety of other ways you can calculate the effect sizes if you're not able to do it the way that I show you. But everything else should be pretty much the same. Okay, so when we open up SPSS, the first thing we need to do is to load in our data file. So I'm going to select Open Another File to navigate to where I have it saved on my computer. You also need to change this to all files down here, the files of type. By default, it's set to only load SPSS files, but you want it to look for all files, right? So we'll go ahead and do that. And then once we do that, just navigate to where you have the file saved on your computer. And here is my file. My file is saved as a text file, a .txt file, but of course you could also load in CSV files, comma separated files, Excel files, SAS files, whatever the case may be, right? And just in this particular example, I'm loading in a text file, but the process is still the same. So we'll go ahead and select our file. What I have is data that looks at differences in study hours between men and women college students at local campus. And now we're going to be taken through the import wizard. Okay, and so this is where we're going to make sure that our data is loaded correctly. And so in this particular case, I have two columns of data. Each column corresponds to a variable. The first column is my grouping variable, which consists of zeros and ones. The zeros represent men and the ones represent women. That's just how I've coded it. And then in the second column, I have study hours, right? So each participant responded and said on average how many hours per week they spend studying. So the first row that corresponds to the first person, the 0 lets us know that they are a man, and the 8 lets us know that they've responded that they study 8 hours per week. All right. And so I'm just making sure that I have, it's recognizing that these are my two columns of data. And it looks like we succeeded on that count. So we'll go ahead and select next. You don't need to really change anything here yet. The only thing you might need to do here is that depending on how your data is formatted, you might need to change from delimited to fixed width, right? By default, it's set to delimited. Delimited means that your columns, your variable columns, are separated by some sort of symbol, whether it's a blank space, a white space, whether or not it's a tab, whether it's a comma, period, whatever the case may be. There's some sort of specific thing separating your data columns, right? And again, if it looks correct in your data preview, then you're good to go. Okay, so go ahead and click next. And now it says the first case of data begins on which line number. Um, I do not have variable names in my data file, right? So for me, the first case of data begins on line 1, so that's correct. If you have variable names already in your data, like in a lot of Excel spreadsheets, then this would be switched to 2, right? Because the second line is where your data starts. The first line would be where your variable name starts. So for me, this is correct. My data starts on line 1. All right, and now it's asking me what specific character is spacing out my variables, right? For me, it's a tab. If you don't know how your data is spaced out, well, again, just look at your data preview. This is how we want it to look. If it looks like this, where everything's jammed into one column, that means that you have the incorrect delimiter selected. So if all else fails, you can just try and see which one makes it so that your data is then spaced out correctly in 2 columns. So you see how I just did there. I just cycled through, then saw that a tab was how my data was spaced out. If it's a blank space, then you would select it as a blank space instead. But yeah, so we'll go ahead and proceed. So now I'm going to specify the names for my variables. Again, if yours already has variable names, you don't need to do this. For mine, my first column is gender. Okay, and then I'm going to select my second variable to change the name of that to study hours. All right, and then I'm going to select next, and sure enough, down here in my data preview, it looks good. Gender, study hours, we're good to go. I'm going to select finish. And now my data is loaded. Okay, so this is the data view. We have a data view and a variable view. So this is the data view. Now, in my case, I need to change this because you look at these symbols up here at the top, right, and we see that SPSS um, set this up so that my study hour variable is a nominal measure, right? It's basically treating it, it's not treating it as the correct type of variable, which is a scale variable, a continuous variable. So I need to change that. So I'm going to go to my variable view, and I'm going to go to the measure and for study hours, I'm just going to change it to scale. So again, this row corresponds to study hours. All I did was click measure and then select it to scale. My gender variable is correct. That's a nominal variable, so that's good to go. You don't need to do this if it's already, correct. This is only because in my instance, SPSS for whatever reason had recognized study hours as being a nominal variable. So I just had to go in and change that. And then the other thing I need to do is I need to make sure that I set it up so that it knows that the 0 represents the men and the 1 represents the women. So what I'm going to do is I'm going to click on the values for, not study hours, I'm going to click on the values for gender rather, and then I'm going to click on these little 3 dots here. And now I'm going to type in 0, that corresponds to men, and then I'm going to add 1 corresponds to women, and I'm going to add, and then I'm going to click OK, and now I'm good to go. So instead of it just, printing out my output in terms of 0 and 1, now it'll print it out in terms of men and women. Okay, and again, the way I did that was by selecting values for the gender variable and then changing it through that way. Okay, so now I'm going to go ahead and I'm going to run my analysis. So I'm going to go to Analyze, Compare Means. Again, this is where we're going to be looking at an independent samples t-test because there's no relationship between our two samples, right? We have men and women, and there's no relationship. It's not like they're husband and wives. It's not like they're twins or anything like that. We're just going to go ahead and treat these as independent groups. So we will go to the independent samples t-test. The test variable, that's going to be your response variable, which is study hours. We're looking at the differences in study hours between men and women. And then gender is going to be the grouping variable. Okay, and now you see these 2 question marks that popped up. Well, I need to define my groups. Okay, so I'm going to select define groups and let SPSS know that, hey, group 1, that's the zeros, people that are coded as zeros, and then group 2, that's going to be the ones that are coded as 1. So we'll go ahead and click continue, and now it says gender in parentheses 0 and 1. And again, I did that by clicking define groups. All right, and now it's the box that says estimate effect sizes is checked. That's what I want. I'm not sure if all the older versions have this. This might be that one difference I was talking about. But for the newer versions of SPSS, it does have this. Okay, but you can still run the t-test without this if you don't have this on your older version of SPSS. The options would give us the ability to change the confidence interval that gets printed out. We're going to leave it on 95%. And then if we wanted to run a bootstrap t-test, we could select bootstrap, but we don't need to do that. So I'm going to select OK now. And now I have run my analysis. There's one more thing I need to do though, and I'll explain why I need to do it after we do it. So I need to go to Analyze, and I need to go to Descriptive Statistics. I need to go to Explore. I need to drag my study hours over to dependent, gender over to factor. And what this is going to do is this is going to give me my descriptive statistics separated by gender. So I'll get my descriptive statistics for the men and the descriptive statistics for the women separately. The reason I want to do this is because I need to find out the variance for my first sample, the men, and the variance of the study hours for my second sample, the women. And I need those variances because I need to determine whether or not it's appropriate for me to use the equal variances or pooled variances t-test or the separate variances t-test. And I'll talk about that in a second. We'll go ahead and select OK to run that. And now we have this printout of descriptives, and we see that it's separated by gender. So we have the mean for men and the mean for women. And then the variance for men, which is right where my cursor is, 10.08. And that's the variance in study hours for men. And then the variance in study hours for women is 3.917. The reason I need to do that is, like I said, if we look at our independent t-test samples results, we have two rows. The first row is the equal variances assumed t-test, and then the second row is the equal variances not assumed t-test. These are also called the pooled variances independent samples t-test and the separate variances independent samples t-test. A lot of people make the mistake, including myself, of using this Levene's test for equality of variances to determine whether or not it's appropriate to use the pooled variance t-test or the separate variance t-test. Don't do that, okay? This Levene's test for equality of variances is very susceptible to sample size, okay? That's one of the problems with it. So if you have a really large sample size, it will tell you that your sample variances are significantly different, even if it's really just a trivial difference. So instead, we're just going to do something a lot simpler, okay? And what we're going to do is we are going to just look at the variance in study hours for the men and the variance of the study hours for women, and we're going to look at the ratio, okay? And the reason why we had to ask SPSS to give us those descriptive statistics by gender groupings is because SPSS only gives us the standard deviation by default for our group statistics, right? You see up here on the top where my cursor is, it gives us the standard deviation. Now, we could just square the standard deviation, of course, to get the variance, right? But I wanted to show you how to get the variance directly by group as well. But again, it's probably quicker just to square your standard deviation for men and then square your standard deviation for women and then look at the ratio of that. But instead, if you don't want to do the math, you can do what we just did and go to Analyze, Descriptive Statistics, and then Explore, and then get these descriptives. So, okay, so back to our example, we see that our the variance for the men is 10.08, the variance for the women is 3.9. So if I look at the ratio for the men and the women variances, right, 10.08 divided by 3.917. Again, that's my ratio of the variance of my two groups, whatever your groups are. And then I see that the ratio is 2.57. Okay, so the recommendation is that if you have a ratio that is greater than 5, then you should use the separate variances independent samples t-test. If it's below 5, like ours is 2.57, then you can use the pooled variances t-test. Okay, so again, I am looking at the ratio of my sample variances to determine whether or not I can run a pooled variances independent samples t-test or a separate variances independent samples t-test. Okay, so these are both still independent samples t-tests. It's just we're determining whether or not to use the equal variance independent samples t-test or the separate variance independent t-test. So in our case, because this is below that ratio, that cutoff of 5, we're going to go ahead and assume that it's safe to assume that we have equal variances. Okay, if it was greater than 5, you would use the separate variances. Okay, one more note: if you have significantly different sample sizes, I shouldn't say significantly. If you have unequal sample sizes, right, like ours are pretty close, 24 men, 25 women. If you have different sample sizes, unequal sample sizes, it's probably best to just go ahead and use the separate variances t-test. You can skip over this whole thing about the ratio of the sample variances. But again, that's only if you have unequal sample variances. So if you have not unequal sample variances, that's if you have unequal sample sizes. So if you have unequal sample sizes, go ahead and just use the separate variances samples t-test. If you do have equal sample sizes, then you can look at the ratio of your sample variances like we just did. If that ratio is above 5, then use the separate variances t-test. If it's below 5, use the pooled variances t-test. Okay, so again, ours was below 5, so I'm going to use this equal variances assumed t-test. If it was above 5, I would use the equal variances not assumed results. So looking at our results, here's our t statistic. Okay, it's 4.762. My degrees of freedom are 47, and my two-sided significance is less than 0.001. So in this example, the men did have a significantly higher average study time than the women. Okay, in real life, this is probably not the case. Again, this is just simulated data, but in our example here, we do see that, hey, there is a significant difference, and specifically the males studied significantly longer than the females on average. Here's the confidence interval for the raw difference, right? So we are 95% confident that the difference in study time between men and women on average falls between 2.07 and 5.097. So we're 95% confident that the men have a larger average study time than the women, where that value would fall between 2.07 and 5.097. Notice I didn't say there's a probability that that's the case. I just said that we are confident that that's the case. Okay, and then our effect size right down here, this is our point estimate for Cohen's d. So our Cohen's d is 1.361. Again, this is the standardized difference in means. And here is the confidence interval for Cohen's d. So 0.731, 1.979. The benchmarks for Cohen's d that a lot of people follow are 0.2, 0.5, and 0.8 for small, moderate, and large, right, respectively. So ours is definitely large. It's 1.361. That's a large effect size. Okay, and so this is we have everything we need to run our write our summary statement. And again, so this is all you need to do to determine what your results are. What I'm about to show now is how you would maybe write an APA format write-up. So we do see already that, again, there is this significant difference between men and women on average. This is our p-value, and then this is our confidence interval. And again, the way we would interpret this is that we see that on average, the men studied significantly longer than the women. Okay, and so to export my results, I'm going to go to File, Export. I want to change the objects to export to all visible because I want to eliminate this background syntax that's running in the background. If you leave it on all, it'll print out a bunch of garbage that you don't need. So change it to all visible, and make sure that you have your document type set to a Word document if that's what you want. Sometimes it'll be a couple of other different file formats. We want a Word document. So I'm going to go ahead and press OK. And it's going to save it as a file called output, and it tells you where it's going to save it. So I'm going to go ahead and save it. Then I'm going to go to where it's saved. I'm going to go to my output. And then here we go. So this is that same output that we looked at before. Okay. Now note that it kind of jammed it. It couldn't fit it all on one page, so it split it up into, or all in one row rather, so it split it into two rows. You can also change to landscape and see if that helps. Not really, it didn't help us. It still split us into two rows. So anyways, the important thing is that you can see your results and that you can, read them legibly. So we still see everything that we saw in SPSS. So now I'll give a quick example of how we could write an APA style statement of our results. And so what I would probably say is something like this. I hate that font size. Let me change that to Arial. Actually, that's a little easier to read. Okay, so what I would say is something like this. Among college students at East Carolina University, men had significantly, or I would just say men spent significantly more time studying on average, and then I'll write those statistics. So the mean for the men, the standard deviation for the men, and again, this is an APA format, the way I'm typing this. So among college students at East Carolina University that participated in the study, men spent significantly more time studying on average than women. And then I'll write the women's mean, which was 4.00, and then the standard deviation was 1.98. And now I'll give the results of the statistical test. So I'll write T in parentheses, and then my degrees of freedom, which is 47. I can remember I got this from my SPSS results. And then the T statistic is 4.762. And then the p-value was less than 0.001 because we used a two-sided t-test because we didn't have a specific hypothesis about the direction. Okay, and then I'll include my Cohen's d value, the point estimate, which was 1.3. Point estimate was 1.361. Okay, and so what we have here is it says among college students at East Carolina University, and we can probably even get rid of this part. We'll just say among college students at East Carolina University, men spent significantly more time studying on average than women. And again, you can tweak the way you word this a little bit. And then we give the means for the men, and the standard deviation for the men, the mean for the women, the standard deviation for the women, the t-test, the p-value, and the Cohen's d. And then now we'll include our confidence interval. And so we'll say a 95% confidence interval where the difference in means runs from, and then we'll look at where our confidence interval runs from. And again, we had the equal variances assumed for this example. So that's going to be, it runs from 2.07 to 5.10. In raw units, because again, this was our raw unit confidence interval. It's not the confidence interval for the standardized units, which is the confidence interval for Cohen's d. So a 95% confidence interval for the difference in means runs from 2.07 to 5.10 in raw units. And then I'll give the interval for the Cohen's d, which is the standardized units. And the Cohen's d confidence interval is 0.731 to 1.98. Okay, so again, among college students at East Carolina University, men spend significantly more time studying on average than women. Results of the t-test. Then a 95% confidence interval for the difference in means runs from 2.07 to 5.10 in raw units and 0.73 to 1.98 in standardized units. And again, that's the confidence interval for the difference in means in just regular units, and then the confidence interval for Cohen's d, the standardized units. And now you are pretty much done. I'll show you one other tweak you could have made to the way you wrote this. And we could have also, instead of saying that the confidence interval runs from blah to blah, we could have just done this right after our p-value. We could have put 95% CI and then in brackets 2.07, 5.10, right? And so this way, the 95% confidence interval is just included right after our p-value. And then we could do the same thing for D. So either way, either one of those ways would have been fine. And so again, just to recap, men did have a significantly higher average study time than women, and that difference in means, so the difference between the mean study time for the men and the study time for the women, the difference in means was significant, and that difference in means was 3.58 because the men studied 3.58 more hours on average than the women. And but yeah, that's pretty much it. So now we've covered how to load our data, run our analysis, and write up our results in APA format.